Hey everyone, I'm Damien, a solution architect at AWS. I'll present a reference demonstration using Amazon CloudFront for secure streaming delivery using Common Access Tokens and CBOR Web Tokens. So what does that all mean? Every streaming platform faces a similar challenge. How do you securely protect content at the CDN edge without adding latency? Today, most CDN providers use proprietary token schemes. If you're a content provider distributing your media content with Amazon CloudFront and multiple third-party CDNs, you may need different token formats, different signing libraries, and different validation logic for each one. That's a lot of implementations to build, test, and maintain. And the tokens themselves, most platforms use JSON Web Tokens, or JWTs. They work well, but they're text-based and verbose. At the CDN edge, every byte matters. Larger tokens mean larger headers, slower parsing, and tighter URL constraints on some devices, especially for HLS streaming, where tokens need to propagate through manifest and segment requests. So the industry developed a standard. One token format that works across CDNs, is compact enough for edge processing, and is built on proven cryptographic foundations. That standard is CTA 5007A, Common Access Tokens. This was published by the Consumer Technology Association and defines an interoperable token format built on 3 IETF standards. CBOR, a binary encoding format like JSON, but smaller and faster to parse. COSE, a cryptographic signing encryption for CBOR structures. And CWT, the claims model. Because it's standards-based, a token generated for CloudFront can be validated by any CDN that implements the specification, and there is no vendor lock-in. Amazon CloudFront now supports CBOR Web Tokens and Common Access Tokens. This means token validation happens in sub-millisecond time before the request reaches your origin. In order to explain how you might implement this new module with CloudFront Functions, this web app has an interactive architecture showing the workflow from the video player right through the CloudFront CDN to the origin. So I'll now step through that for the case where there's an authorized viewer needing to play back a video stream. So the first step is the video player makes request back to the API for the media company's CMS or content management system. In this case, it's a Lambda function that is generating the token along with the playback URL for the media stream. This is passed back to the video player, which now has a URL and a token to make the request to the video CDN. In this case, it's CloudFront. Once a request hits CloudFront, it is inspected by the CloudFront function Edge Compute. The claims and signing are checked using parameters stored in the key value store at Edge, but there's no external requests. This all happens within 1 millisecond, and in this case, the claims are checked and passed, and the request can proceed through the Amazon CloudFront CDN, a globally distributed network of points of presence and networks, back to the origin in the AWS region. The video stream is passed back then to the player, which can continue playing the media. Success. Now, in the other cases, the token may fail because potentially there's no token, or an expired token, or a tampered token, which has been modified. So for each of these examples, you can see that you'll get a 403 forbidden request on that video stream. So that's a high-level workflow. Now let's look in more detail at some of the technical specifications. So these tools allow you to, once again, generate a token from the Lambda, and the token is returned as a base64 URL. You can include this URL in the header in your request, or in fact, the standard allows for a query string. And it details the claims, which we'll get to in a minute. I now want to inspect the token. This outlines the nested CBOR tag structure of a common access token for further debugging. You may want to validate the token. So I'll take that previously generated token, I'll validate it successfully, and once again see the decoded claims, which will be inspected. The claims panel outlines the common access token standard claims, which are things like the expiration time of the URL. There are a range of other claims specified in the common access tokens standard, which can be reviewed and implemented, but they're not part of the current demo. There's a lot of detail here to learn and get your head around as a developer. So the links here outline the standards documentation, the IETF standards, give some background to the signing process, the token lifecycle, and some considerations for implementing this in production for a HLS platform. In this case, there's two recommended approaches to using tokens. The first is to insert the token in the URI path. And the second option, potentially, is to insert headers at the player level, if that's possible for your player. Finally, there's some sample code, for example, a curl to generate the token, once again from the Lambda, and a curl to validate that token using CloudFront. So we'll go back and run through the workflow one more time. The player's made a request for the token, validated by a CloudFront function, passed back through CloudFront to the origin, and video playback is successful. So this demo hopefully has explained a bit more about what is possible with CloudFront Functions and CBOR Web Tokens. This is a reference implementation only, but the intent is that you could progress to implement your own Common Access Tokens solution. I hope this is useful. Thanks for watching.